Hi guys. So today we're going to talk about the brain. Before we dive into the structure and function of the brain, which is extremely complex, I want to do a quick overview, a reminder of the big picture of the nervous system as a whole so that we don't get lost in the details of the brain. You remember that in the last section we actually talked about the brain and the spinal cord as being part of the central nervous system. So I'm just going to repeat. Here's my spinal cord. Whoa, sure thing. Totally looks like a spinal cord. Just to remind us about, dude, why are we here? Why are we doing this? What is the brain? Why? What is its overarching role in the nervous system? Remember our little drawings that we made that included the central nervous system and the peripheral nervous system. And remember how we had sensory little receptors receiving sensory information from the environment, and they actually transmitted that information to the spinal cord. Do you remember that? And then remember that, we have different flavors of sensory information, but then ultimately we have some sort of action that can be carried out. And we have different flavors of efferent pathways. We have different ways that we can, or different types of efferent pathways. But the bottom line is that somehow sensory information can come in. It can be processed in the central nervous system, and it can then send a message out to make something happen. For example, to make you contract a skeletal muscle. Today, our primary task is to look at who bridges the gap between the sensory information coming in and the action that happens as a result of that sensory information. Sometimes the central nervous system really doesn't do much. Sometimes it literally does nothing. Sometimes you can actually have a sensory neuron synapse with a somatic motor neuron, and you would actually end up with some kind of a reflex where there is no processing in the central nervous system. There is no integration. It's actually automatic. That's not the norm. That's not the most common. We are going to talk about some reflexes in the next lecture. But for right now, we're going to focus on, okay, information comes in, but now we're going to hop on to one of our tracks in the spinal cord, one of our white columns in the white matter, and we're going to head up to the brain. And we're going to send a message to some part of the brain where the brain will then decide, okay, this is what we think should happen, and send the message back down. Now's a great time to whack somebody upside the temporal bone with your olecranon. And then your skeletal muscles will carry out that task. How is our brain doing this? How does our brain actually carry that out? That's the topic of today's lecture. Before we dive in to that friendly little complicated structure, that fantastically complicated structure, we are going to look at how your brain developed from when you were just an itty-bitty cute little zygote.